Black holes. A lot of us, when we think of black holes, we usually think of some big, destructive abyss in space that just sucks up everything in its path. But what really is a black hole? By definition, a black hole is a celestial body with such a strong gravitational field that not even light can escape, hence the name black hole. At a distance, black holes act just like any other massive celestial body would, in that they just orbit and interact like any other star or planet. However, it's when you get closer to a black hole that its effects become really apparent. A black hole is so dense with such a strong gravitational pull that it physically warps space-time, so as you get closer, time starts to slow down. Around the perimeter, bits of dust, gas, and even stars that are too close start to warp, heat up, and accelerate as they're pulled towards the center of the black hole. This all creates an almost incomprehensible amount of force near the event horizon, the boundary right before you enter the black hole. This is known as the point of no return. Time slows down almost infinitely. You can see absolutely nothing inside before finally being pulled in and annihilated by the sheer force of gravity. This point is called the singularity. No modern physics or quantum physics laws can explain what happens inside. But I'm sure you're probably wondering, how do black holes even form? Well, scientists believe that some of the smaller ones formed when the universe first began, but many black holes usually begin with the death of a large star. A star keeps its composure when the two opposing forces acting on it stay balanced. There's a surrounding gravitational force that pushes inward, while a counteractive pressure pushes outward. This outward pressure is fueled by the nuclear fusion that takes place inside the core, where the star continually converts hydrogen to helium, then helium to carbon, and carbon to oxygen, and a whole host of other elements until it finally ends with iron. Once iron is formed, the nuclear fusion in the core stops. The star runs out of the energy maintaining the outward pressure, and the surrounding gravity collapses the star. This sudden collapse causes the star to implode and then violently explode as a supernova. Then gravity continues to collapse the core, finally forming a black hole. Some of the largest black holes, which are quite literally called supermassive black holes, are located at the center of large galaxies. These black holes are 100,000 to about 20 billion times the mass of our sun. Mind-boggling, right? Well, we have a supermassive black hole right at the center of our Milky Way, named Sagittarius A star. It's about 4 million times the mass of our sun, and at about 26,000 light years away, it's the closest known black hole in our local galaxy. Recently, a new black hole was just discovered this year. It's the most massive black hole ever found to date. It's 40 billion times the mass of our sun, which is so insanely massive that astronomers had to create a whole new category for it, calling it an ultramassive black hole. It's located in the Homebird 15A galaxy, about 700 million light years away. If you want any more information about this, I'm going to be linking some really cool articles I found in the description down below. My name's Jordan, thanks for listening, and if you like this video and maybe feel like you learned something, then give it a big thumbs up. Alright, that's it. Bye.